Welcome to You Got Hope Science. I'm Hope, and you're about to learn some science. In today's lesson, we are going to do some basic math skills before we get into the unit of physics. These math skills we will learn over the next few lessons will apply to many science courses, whether it's bio, chem, physics, or general science, even mathematics. You will come across these different skills many times, and it is important that we get a good foundation to build upon. In section 1, we're going to look at measurements, and then we'll look onto significant digits, as well as scientific notation and some basic arithmetic. So the first thing we want to talk about is measurement. Measurement can only have one uncertain digit in the measurement itself. What that means is when you make the measurement, you're going to come to a point where you're not quite sure it is this or that. That would be an uncertain digit. I'm not sure if this is 0.7 or 0.8. I'm going to pick 0.7. That's a certain amount of uncertainty. You're only allowed to do that once in any kind of measurement. So for instance, when we look up here, we can say that there's absolutely 10 millimeters, 11, 12, 13, 14, 15, 16, 17, and this is 18, even though it's a little bit past 18. We have to guess what that little bit is. That is our uncertainty. So we are certain there is 18 millimeters, but there's a little bit more. I don't think it's quite half. I'm going to say it's 0.3. To you, it might be 0.4. That would be a level of uncertainty, and that's the maximum I can measure to. So for instance, if I was looking at this measurement, which is in kilograms, I know for sure that this is 10 point something, but it's definitely not 10.1. So now I know this is 10.0, and then there's a number here. This is probably plus or minus one value. So I definitely know it's not 0.05 because that would be in the middle. And this is a little bit closer to 0.1 than it is to 0.05. So I'm going to say 10.08. This is my uncertainty. Maybe it's 0.07. Maybe it's 0.09. But that is my level of uncertainty in this measurement. So what I would like you to do at this time is pause the video and try to figure out what the measurement is for B as well as for C. Now that you've had the time to do that, I'm going to go through it with you. So I know for certain that this question here is 0.0080 something. I know that because this is 0.0080, which I have, and the maximum it can go up to is 0.0081. So I know it's somewhere in between that value. So I'm just going to guesstimate that this is about halfway. And I don't think we're halfway to the halfway point. So I'm going to say that it's 0.00802. Now it could possibly be 0.0028025. 0.008030 or 15. I don't know. And because this is uncertain, this is as far as I can go. I can't say 0.008025 because that would give me a second uncertain digit, which is not allowed. Moving on to the next one. I know for sure that this is 1.0 something 1.03 something, because I know that this isn't 1.04, which is here. It's got to be less than that. So I count 1, 2, 3, 4, 5, 6. Now it's a little bit more than that. So I know that this is 1.036 for sure, but then maybe it's 1.0361. Maybe you pick 2. I don't know, but that's my level of uncertainty. I know for sure it's 1.03, for sure 6, it's not 7. This number I just don't quite understand, and so it's an educated guess, and that's my level of uncertainty. The next basic math skill we're going to look at is significant digits. In shorthand, we write sig digs. So sig digs kind of represent how accurate a measurement can be, and there are a set of rules to follow to figure out how many significant digits you have in a certain number. So the first thing I want to talk about is actually definitions or actual counting. If I have a loonie, which is $1, I would never say it's 1.00000000000 on for infinity accurate, because it is a dollar. You can't get any more accurate than that value. It actually is $1. I can't give it more accuracy other than that the fact that it's infinitely correct. $1 is $1. I can't call it 1.0000000 because it is infinite zeros. So when you have an actual object or a definition, or you're counting something up, it's essentially infinitely accurate, and it doesn't have amount of significant digits. But if I'm measuring out a piece of wood, I can go very, very far into how accurate I'm measuring. I could go to a nanometer, not just a meter or centimeter or millimeter or micrometer. I could go to a nanometer, which is very, very accurate. But that depends on the measurement instrument I am using. We're only as accurate as the instrument that we're using to measure something. So let's start talking about significant digits based on a number recorded on a measurement that was able to be reached. So for instance, when we look at A here, I have 0.0040 grams. There is an extra 0 at the end here, which is telling me that this is for sure 0.004, and then this probably could be a 1 or a 0, a number in between, but most likely between 0 and 5. Under that value, over that value would round. So the number of significant digits in a value is determined by first locating the non-zero digit from the left. So for instance, starting on the left, this is 0, I cross it out, that doesn't count. 0, that doesn't count. 0, that doesn't count. My first real number. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is what I'm looking for in this spot. Every digit, including that digit and the digits that follow, are significant. So the 4 is significant and the 0 is significant. So I would say that there is 2 sig digs, or significant digits, in that value. For B, this is a real number. It's not 0. So this number and every number that follows is significant. So I have 1, 2, 3, 4, 4 significant digits. Now with letter C, this is something that I've counted. I've counted 6 tables. This is infinitely correct. I'm not going to say 6.0 infinitely long tables. I'm just going to say that there is for sure 6 tables. This is an infinitely correct significant digit. It's not really a measurement. It's something that we're counting. What I would like you to do at this time is pause the video and try to answer D, E, F, and G in terms of significant digits. Pause the video now and give it a try. Now that you've given that a try, let's go through the answers. So what I'm looking for is my first real non-zero number to the left. So I've got 0, it doesn't count, doesn't count, doesn't count. 5 is my first real non-zero number. This number and all numbers to the right of it are significant. So that would be 5, 0, and 7. There are 3 significant digits in that value. Looking at E, I start on the left, try to find my first real non-zero number. 4 is not 0, and it is a real number, so this number and all numbers that come after it count as being significant. 1, 2, 3, 4, 5. There are 5 significant digits in that number. For F, I start on the left. I get a 0 to start, another 0, another 0. They do not count. Once I hit my first significant digit, all numbers after it will count. So 1, 0, 0, 3, 0 would count. This would be 5 significant digits. Now, anything which is a definition or something that we literally count is an exact value, and we do not have any uncertainty. This is infinitely correct. This is infinitely accurate. 1 meter is exactly 100 centimeters, and that is infinitely correct, so I do not have a number of significant digits. In our next section, we're going to look at scientific notation. Scientific notation is something you will come across plenty throughout your high school career. Scientific notation uses a system of times 10 to the power of in order to give numbers the opportunity to get into the right number of significant digits or to make a value easy to read. So for instance, if I had to write the number of light years in hours to Mars or to the moon, it would be an enormous number. It would be so long. And if I have to keep my measurement within a certain number of significant digits, it would be impossible to write that number. So scientific notation allows us to write a large number, say like 84,170 seconds, into a system that's a little bit smaller. So it's an actual value between 1 and 9, decimal, another value, times 10 to the power of that number of whatever unit you might be. So for instance, if I'm looking at question number 3, and the question asked me to put this in scientific notation and to assume 3 significant digits, what I first have to do is take this value and have a non-zero real digit to start. And then I would put a decimal followed by the number of significant digits times 10 to the power of what it would be. I know that sounds confusing, but let me start at the beginning. This would start as being 7.00. This is 3 significant digits, my first real non-zero number. Decimal 2 numbers after it, that is 3 significant digits. Now I have to write this to times 10 to the power of some value based on which way the decimal moves. So because the decimal has to move to the right 1, 2, 3 spots in order to make this 7, I have to make this times 10 to the power of 3. However, because we are moving to the right, this is the power of -3. To the right is a negative value in terms of unit adjustment. So this is 7 times 10 to the -3 meters. Looking at our next one, I would start at where the decimal place would be, which would be right here. And then I would write down my three significant digits, starting with my first real non-zero number, which is 7, then 8, then 0. So 7.80. Those are my three significant digits, times 10 to the power of. I then move the decimal to the left 1, 2, 3, 4, 5, 6 spots in order to get the decimal in this spot. Now, because I moved to the left, this is a positive power of. So this is 7.80 times 10 to the power of positive 6 seconds. I'm going to do one more with you before I get you to try some on your own. So looking at the next value, you can see how awkward it is to write all of those zeros, and this seems quite bizarre. So in order to put this into scientific notation, I start at my first real non-zero number, which is the 6. I need 3, so 681. I would write 6.81 times 10 to the power of. I move the decimal over 1, 2, 3, 4, 5, 6, 7, 8 spots. So that's an 8. But because it's to the right, that's a negative value. So negative 8 kilograms. I would like you to pause the video now and try D, E, F, and G. Now that you've had an opportunity to do that, let's go through the answers. So looking at letter D, I can see that I have three significant digits when I underline these three, 1, 2, 3, but I'm going to check the number behind to see if it rounds up. So 8 rounds the 9 up, which is going to cause the 1 to round up. So this would be 5.20 as three significant digits due to the rounding and then subsequential rounding. This is times 10 to the power of. I got to move the decimal place over 1, 2, 3, 4, 5 spots. So 5. Because it's to the left, it's positive. And then the unit would be in meters. Going on to the next one. I need three significant digits. So starting on my left, I find my first real non-zero number, 2, 3, 0. Those are three significant digits. The number behind does not round up. So this would be 2.30 times 10 to the power of. I then move my decimal place over 1, 2, 3, 4, 5, 6, 7 times. Because it's to the left, it's positive, so times 10 to the power of 7, and in this unit, grams. On to the next one. Find my first real non-zero number, 3. 3 digits together, 3.4. This 7 gets rounded up by the 9, so that's going to be 8 times 10 to the power of. I move my decimal over 1, 2, 3 spots, so that's negative 3 seconds. The next one, I underline my three significant digits. The 9 rounds up the 9, which rounds up the 9, which rounds up the 1 to become 2.00 times 10 to the power of. Moving the decimal over 1, 2, 3, 4, 5 times to the left, that's going to be positive, so to the power of 5 meters. And our last one, we find our first three significant digits, 480. We check for rounding. This does not round up, so 4.80 times 10 to the power of. We move the decimal place over 1, 2, 3, 4 spots to the right. That's negative. to the negative 4 grams. In our next section, we're going to look at arithmetic with measured quantities. Essentially, we're going to look at figuring out the number of significant digits when we are adding, subtracting, multiplying, or dividing numbers which have different numbers of significant digits. So the first one we're going to look at is addition and subtraction. Now, first of all, when we do addition or subtraction, whatever unit we're doing our calculation in, everything has to be in the same unit. For instance, centimeters or centimeters. So if one of these values was initially millimeters, we would either have to convert one of them to centimeters, so they're both centimeters, or one of them to millimeters, so they're both millimeters. You cannot add or subtract values with different units. Now, the rule is when you're trying to figure out what the number is going to be as an answer, you have to answer to the least precise measurement. So for instance, this value is measured to 1/10 of a centimeter, and this value is measured to 100th. This is least precise because we don't have that extra value after the 100th, which means my final answer has to be to 1/10, not to 100th. Now the actual value that comes out here is 654.35 centimeters. Now, I would then underline my significant figures, which is to the least precise measurement. And then I would circle the number that comes directly behind it. This number is the one that dictates whether we round up or down. So, because this is a 5 or larger, this would round that 3 up to a 4, which is what our final answer is. But if this number was instead a 4, it would stay as a 3. It would not round it up. So if this was a 0, 1, 2, 3, 4, it does not round up. If it's a 5, 6, 7, 8, 9, it does round up. This is the rule for adding and subtracting, which is different from the rule for multiplication and division. In multiplication and division, the answer has the lowest number of significant digits that you are working with. So for instance, 6 is my first real non-zero number. All of those digits that happen after it are significant. This is 5 significant digits. 4 is my first real non-zero number, and everything after it is significant. So this would be 3 significant digits. All I do is pick the 3 digits, which is the smaller of the two values, as my number of significant digits. So I know that when we add these together, it's 323 newtons per second. Now, the number that comes after the 3 must be 4 or smaller when you punch it in your calculator. And a newton times a second is a newton second. The units do not have to be the same. They just do that mathematical operation, which it is done on them. So for instance, if I have a meter and it's divided by a second, that would be a meter per second, which is a unit we use a lot of in physics. So let's try some practice questions. Let's do A and D together. A is adding and D is dividing, so they go by a couple of different rules. And let's begin. So the first thing I'm looking at is the fact that we have an addition sign. Anytime we have an addition or subtraction sign, everything has to be the exact same unit. So centimeters, 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 I know I'm good there. If they weren't, I would have to adjust the measurement so it's at the same unit, which is what we're going to look at in our next lesson. The next thing I'm looking for is how many decimal places, or how accurate is this measurement. So this one is to 1 decimal place, this is to 2 decimal places, and 2 decimal places. Our answer has to be to the least accurate measurement. So these are gone. My final answer has to have 1 decimal place. So when you punch these three numbers into your calculator, you will get 22.14. Now the unit has to be a centimeter. Based on the number of significant digits, which is to a tenth, I have to go to this point. I circle the number behind it. 4 or lower does not round the number up. 5 and higher does. Because this is 4 and lower, it does not round the 1 up to a 2. My final answer is 22.1 centimeters. For question D, I'm dealing with division. Now the rules are different. I don't have to have the same unit, first of all. And the second thing is, it's not the number of decimal places, but the number of significant digits in the number that matters. So for our first number here, this is 4 significant digits. And for our second number, this is 2 significant digits. The number which has the least number of significant digits is the amount of significant digits you need in your answer. So I need to have 2 significant digits. When you punch this in your calculator, what you would get is 1.337. What you would do is you would underline your 2 significant digits, circle the number behind those digits, check to see if it rounds up, which it doesn't. So my final answer is simply going to be 1.3. I have to make sure I have a correct unit. A meter divided by a meter would cancel the meters out, just like if I had 2 over 2, that would cancel out. There's actually no unit for this measurement. What I would like for you to do at this time is try B, C, E, F, G, and H. Pause the video now and do those questions. Now that you've had the opportunity to do those questions, let's look at the rest. First thing I notice is this is a minus sign, which means we have to follow the rules for adding and subtracting, which is the least number of decimal places. So I need to the 10th here. When I punch this in my calculator, I get 6.97. I need 2 significant digits because of that value, so I underline them. The number behind determines the rounding of the number in front. This rounds this up to a 10, which means this rounds this up to a 7.0. And because the units are the same, it's the same unit of grams because it's adding or subtracting. For C, when you punch this in your calculator, you get a value of 14.39146. Because both units are in seconds, this is in seconds. And then I have to go to the least accurate measurement is to 100th. The least accurate measurement to 100th goes 39. I circle the number behind that, check to see if it rounds up. It doesn't. So this would simply be 14.39 seconds. For letter E, we're dealing with a different set of rules. We're now multiplying. So we need to count out the number of significant digits in each number. So this would be 3 significant digits, and this would be 2. So I need to have 2 significant digits in my answer. I would punch this value into my calculator, which would give me 6.825. That's the number value, but because this is liters times liters, that would become liters squared. I underline my 2 significant digits. I circle the number behind. This number does not round up, so this is simply going to be 6.8 liters squared. All right, for letter F, we are also multiplying. So we look at which number has the least number of digits as a decimal point. This has 1, 2, 3, 4, 5. This has 1, 2, 3 to the 1,000th. So my number has to go to 1,000th. When I type these numbers in and I multiply them, I get 0.3399816. Now, in terms of a unit, this is a kilogram, which is a kilogram over 1, times a meter over second. So this would be a kilogram times meter per second. In terms of the number of significant digits, I need to go to the 1,000th. I underline, circle the number behind. This number determines rounding. This will round up the 9 to a 10. That rounds this up to 4. And this would simply be 0.340 kilograms times a meter per second. For letter G, I'm going to double bracket the numerator to make sure my calculator knows that that has to be done as one step, and then divide by my denominator. Now, because this is multiplying and dividing, I have to follow those rules. So, this number here has 4 significant digits. This one has 2. This one has 4. I need the least number of significant digits. When you punch G into your calculator, you're going to get 4.806736 and a few more numbers. I'm going to underline my 2 significant digits, which would be 4.8. Circle the number behind. This does not round up. This is simply going to be 4.8. Now, in terms of the units, the seconds on the bottom would cancel with seconds on top. Meters times nothing else would simply be meters, and this is 4.8 meters. For the letter H, I have to check out what number of significant digits each number has. This is 3, this is 4, this is 4. I need to have 3 significant digits because it's the smallest number. Punching this in our calculator, we get 0.6201278, a bunch more. Now this is a meter over a second times a second, which would be seconds squared. This is the unit of acceleration. I'm going to underline my significant digits, which is 3, circle the number behind. This does not round up, which means my final answer is 0.620 meters per second squared. Thanks for watching You Got Hope Science. I hope you enjoyed the lesson.